Hello everyone, my name is Anish Kumar from SVCE ISA department. The topic which we're going to discuss about right now is real-time operating systems for microcontrollers. In this video, we're going to know what is a real-time operating system and how it is very useful when it comes to microcontrollers and how real-time operating systems can actually shape our future in a better way. Even today, real-time operating systems are used in a lot of devices, and even in the near future, it's going to be very useful. So without any further delay, let's continue with the topic. So what we're gonna discuss about today is RTOS, like what is RTOS and all that, microcontroller, applications of RTOS, characteristics of RTOS, function of RTOS, different RTOS for microcontrollers. So firstly, what is an RTOS? Well, RTOS stands for real-time operating systems. So if an operating system has to give input within a tightly constrained time frame, then it is a real-time operating system. What does this mean? As soon as you give an input, the output should be received very fast. So the duration between the input and the output should be really less, only then it can be known as a real-time operating system. So we can take the example of a car. Example, an accident occurs. So what happens when an accident occurs? The airbags just open up. That is done with the help of real-time operating systems. So as soon as the car gets to know that accident has occurred, the airbags just open up. How does this happen? Well, that is with the help of real-time operating systems. And also it should be really fast. Imagine if the accident occurs and the person has already lost his or her life, no gender discrimination, his or her life, and then the airbags open up. Well, that would be completely useless. So the real-time operating systems makes sure that as soon as the accident occurs, the airbags just open up so the injuries can be minimized. So it is time bound and has fixed deadline. Processing must be occurring within specified time period. Otherwise, this can lead to system fail. When we give input, the output should be really fast. Real-time systems respond to input immediately, like whatever I told right now. Like it should respond to input immediately. So what is a microcontroller? Microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller consists of a processor, memory, and input-output peripherals on a single chip. Used in robotics, self-driving cars, washing machines, smart energy, and many other places. Applications of RTOS. Well, it's used in traffic signals, airbag control system in cars, like whatever I told about right now, to handle multiple processes at one time, nuclear reactors, missile launching, and in robots, obviously. Um, in this picture, we can see the components of real-time operating system, the scheduler, function library, fast dispatch latency, user-defined data objects and classes, memory management, symmetrical multiprocessing. So next up, we have characteristics of RTOS. Well, it is extremely consistent because, yeah, it should be consistent. Like, obviously, like if it works once and the next time it doesn't work, well, it doesn't make sense. So it should be really consistent. It is pretty much reliable. Like, you can actually rely on the airbags in car. You can actually rely on your washing machine that it'll just wash your clothes effectively. And next up, we have predictability. So predictability means we know what's gonna happen with the machine. Like whatever we are using, we know what's gonna happen. Like if we actually put clothes inside a washing machine, we know it's gonna wash our clothes. We know that, right? Like we have programmed it in such a way that we know what's gonna happen. And the performance is very good. And most of the RTOS, like earlier RTOS actually had less performance, but it's increasing day by day. People are getting more efficient with the RTOS that's being created. And scalability. What does this mean? Right from very small objects to huge objects. RTOS can be used anywhere, right from small scale to large scale. Like it's extremely flexible, and that is the scalability. So the functions of RTOS: task management, scheduling, resource allocation, interrupt handling, and very fast reaction time. So different RTOS for microcontrollers. Well, I've told you what an RTOS is and all that, but which RTOS to use? Like for example, normal operating systems. Like if I ask you what are the operating systems for a computer, well, you guys would obviously say Windows, there's Mac, there's Linux, and for phones also there's Android, there's iOS, and also Windows phones actually had a operating system, but it was flop. So these are the RTOS which are available for microcontrollers: Free RTOS, QNX, MCOS, VxWorks, and PSOS. So firstly, we're going to discuss about the OG RTOS, which is VxWorks. Well, its application is not just limited to a planet, but even in outer space. I'll tell you why. So it is a deterministic priority-based preemptive RTOS with low latency and minimal jitter. So you're seeing the word preemptive there. What does preemptive actually mean? If there are multiple processes, like example, consider four processes P1, P2, P3, and P4. The one with the highest priority that gets executed first. And example, P2 is the process which is actually being processed right now, and P4 just comes up into the system, and P4 actually has a higher priority. So we stop P4 and we actually shift to P4. I mean, we stop P2 and actually shift to P4 because that has higher priority. That needs to be completed very fast. So we just move to P4. So it is inbuilt on an upgradable, future-proof architecture to help you rapidly respond to changing market requirements and technology advancements. Only RTOS that is used in outer space. Well, where is it used? Do you guys remember about the Mars rover? Yeah, that weird looking vehicle which actually traveled on the surface of Mars. Well, VxWorks was used in it. So applications. Aerospace and defense by including it in over 70 aircrafts and even in unmanned combat aircrafts. So even if a person isn't there inside the aircraft, it can still manage to fly. That is with the help of VxWorks. In space exploration such as Mars, Curiosity rover, like whatever I told about earlier. In latest cutting edge self-driving cars, even Tesla uses this technology. So self-driving cars, like without you actually driving the car, you can actually sit in the back seat, just chill out, and the car actually drives you home or wherever you want. So in critical medical equipments such as MRIs, in robots of all shapes and sizes. Well, next up we have the features of VxWorks. Well, it is IoT enabled, it's upgradable, it is deterministic, safety and security certified, memory protection, and error handling framework. Next up, we have free RTOS. It is distributed freely under MIT open source license. Well, it's downloaded every 170 seconds. Like every 170 seconds, a person actually downloads free RTOS, which is very good. Most used RTOS for microcontrollers and small microprocessors. So yeah, it's most used. Obviously, it gets downloaded every 170 seconds. So it's obviously the most used RTOS for a microcontroller. It includes a kernel and a growing set of IoT libraries suitable for use across all industrial sectors, built with an emphasis on reliability and ease of use. So the features of free RTOS is well, it's Tent, power saving kernel. It supports over 40 plus architectures, modular libraries, MIT licensed. It also has an AWS reference. What are the advantages of free RTOS? Well, it has a trusted kernel, predictability of long-term support. Free RTOS libraries come with security updates and critical bug frame for 2 years. It has a wide device support. Well, you can actually use it in many devices, as I told earlier, right from very small devices to huge devices. You can use it anywhere. Well, it's trusted under de facto standard. QNX. The next RTOS is QNX. What does QNX stand for? Quantum Software Systems. It is a high-performance multi-threaded SMP-ready microkernel RTOS with an open system POSIX API. What is a microkernel? Like when you remove all the non-essential components from a kernel, that's where microkernel comes into picture. What happens here? Well, it actually eases it up because microkernel actually takes up very less space then, and also the security increases. Well, it is used to build RTOS enabled products in every industry where reliability matters. Well, it was developed by BlackBerry, yeah, the famous phone which we once had. Platforms, you can actually run it on ARM32 and ARM64. ARM stands for Advanced Risk Machines, which follow RISC architecture. The characteristics are microkernel reliability, real-time availability, comprehensive, layered security, one of the first commercially successful microkernel OS. So this was the one which actually implemented the concept of microkernel. First, everyone were just using kernel, and this was the one who actually introduced microkernel. So applications, medical devices, automotive vehicles, heavy machinery, transportation, and robotics. So finally, we have MCOS. MCOS stands for Microcontroller Operating System. It is written in C language. Even this follows the real-time microkernel wala approach, whatever QNX followed. It was developed by Jean or John, whatever you'd like to pronounce it as, J. Labros in 1991. Platform, you can use it on ARM Cortex M3 and even on Atmel AVR. The features include multitasking, interrupt management, preemptive, portable, time and memory management, and semaphores. Well, so this was it. Hope you all actually gained the knowledge whatever was required, and hope you all liked it. Thanks for your patience, and we'll get back with another topic, a very interesting topic the next time. So see you guys back then. Thank you.